Hi, everyone. Welcome back. We're on to our second topic that we're going to get into on our unit on bonding. We've already talked a little bit about ions, did a little bit of refresher, built a little bit on that material. But today I want to get into ionic bonding and a little bit of nomenclature and kind of the language of chemistry and bonds and how that works. So let's take a look at what we have today. So we're going to talk about the language of chemistry today. So let's dive right in here. So can you speak the language, right? So let's take a look at how this is broken down. In order to talk about all these chemical bonds and different materials that are found in chemistry, you need to be able to speak in the chemical language. I'm not going to talk to you about how to work on a car without you knowing some of the language that's used for that. So we need to know the language that's used with regard to chemistry and reactions and bonds and that. So in the English language, if we say a word, we think of whatever that word's associated with. For example, if we say cat, you automatically think of what a cat looks like, right? So we want to be able to say something, say a chemical formula or some type of compound, and be able to recognize what that means, okay? Chemical language. If I say sodium chloride, okay, some of you might think of salt, things like that, but we should also know that compound is NaCl, or sodium chloride. So we use those chemical symbols in order to tell us what elements are in that compound, and we need to know, well, what a compound is. So the word compound is a pure substance that's composed of two or more elements. We should know this from previous material, but a little refresher here today. So composed of two elements are chemically combined. So the sentences in the language of chemistry are our chemical equations. These are the reactions that take place. Okay, for example, 6 carbon dioxide plus 6 water plus some energy is going to create glucose and oxygen. This is the reaction that takes place in photosynthesis. So those are our sentences, our chemical equations in chemistry. So our chemical formulas represent the composition of a substance using the chemical symbols and numerical subscripts. So we use the chemical symbols. We looked at a lot of those different elements on the periodic table. We use those symbols and numbers next to those symbols to indicate how many of that atom is in that compound or in that chemical formula. So for example, H2O, water, tells us that 2 subscript that there's 2 hydrogen atoms along with 1 oxygen atom. NaCl, sodium chloride, and CH4, methane. Okay, that subscript is that number found beneath the chemical symbol, tells us the number of atoms. So CH4, methane, tells us that there's 1 carbon. Okay, if there's only 1, we don't need a subscript, but there's also 4 hydrogen atoms in that compound. Okay, so there we have those. So in a bond, in a chemical bond, there's something that occurs known as intermolecular forces. So intra means within. So forces that are within that bond or within those elements. Okay, so intermolecular forces hold atoms together to form a compound. Okay, this is also known as those chemical bonds. This can occur in a number of different ways. We'll get a little bit more into this as we build on our bonding unit. So we already know a little more refresher here. A pure substance is made up of only one type of material. Okay, it's homogeneous. Okay, it can occur in a couple of different ways. If it is an element, such as sodium, okay, it is pure. It can also be a compound made of more than one type of atom, but it can still be a pure substance. If I have a teaspoonful of sodium chloride and it's pure salt, Even though it's made of multiple atoms, it can still be a pure substance. Compounds can occur in a couple different ways. One are salts. These are ionic compounds, and another are molecules. So salts result from the attraction of oppositely charged particles or ions. This is known as an ionic bond. So sodium and chloride ions combine because one is positively charged, one's a positively charged cation in sodium, and another is a negatively charged ion in the chloride ion. And so because of the positive and negative charge, they are attracted because of that opposite charge. Molecules result from the sharing of electrons. This is known as a covalent bond. We'll get into this a little bit later in this unit about how those different atoms share those electrons. So let's take a look at salts since we're going into ionic bonds here. So an example, okay, the most common salt that you all know is sodium and chloride ion. Okay, so sodium has one valence electron and a chlorine atom has 7 valence electrons. Well, if we transfer one of those electrons from sodium to chlorine, okay, the sodium becomes positively charged and the chloride ion becomes negatively charged. They now have an attraction and combine in an ionic bond. A molecule, okay, if I have chlorine with 7 valence electrons and another chlorine atom with 7 valence electrons, okay, they can actually share that one electron so that both atoms appear as though they have a full valence shell, all 8 electrons. Okay, there's a sharing of the atoms right there. Okay, this gives us the molecule chlorine, okay, chlorine gas. So how can we tell if a compound is ionic or covalent? Okay, there's a really easy way that we can tell if something is ionic or covalent. Ionic compounds occur between a metal and a nonmetal. We know from looking at ions already, metals are cations typically and nonmetals are anions. Okay, this can occur as a binary ionic compound, meaning only 2 elements make up that ionic compound. Consists of a metal or hydrogen and a nonmetal. Okay, that metal or hydrogen is our cation, as I mentioned, and the nonmetal is the anion. Can also occur as covalent compounds. 2 or more nonmetal elements combined is going to be a covalent bond. So covalent compounds occur between nonmetals. All right, so how do we write out a chemical formula for an ionic compound? Okay, the goal is to have the positively charged ions and the negatively charged ions balance each other out. So if I were to add all of them together, the net charge of all the combined atoms should be 0. For example, sodium and chlorine, okay, as ions, sodium has a 1+ charge, chlorine has a 1- charge. If I have one of each, I have 1 positive and 1 negative. When combined, they cancel each other out for a 0 net charge. Okay. Lithium oxide. All right. If lithium ion has a 1+ charge, but I have 2 of them, so the net charge for those 2 lithium ions is 2+. Oxygen, an anion, has a 2- charge. So I only need 1 of those to have the same amount of negative charge as the amount of positive charge from the lithium ions. Combine those together with 2 lithium ions and 1 oxide ion, and my net charge is 0. So this is the goal that we want when we're writing our chemical equations for ionic compounds. So we can do this, a way to think about this is using the crisscross method. We want to write down each ion. So when you are trying to determine the chemical formula for an ionic compound, these are the steps that you're going to take. Write down each ion, including its charge. Okay, so for magnesium, I would write down magnesium 2 plus and chlorine 1 minus or just minus. Again, you don't need the 1 there, but we're writing this just to give you a good visual of how this works. Draw crisscross arrows. Okay, so we'll draw the crisscross arrows. The 2 moves over to chlorine and the 1 moves over to magnesium. Then you can rewrite the ions with the compound with those particular subscripts. So we're just transferring the charge over to the other atom, the other ion in that ionic compound. So then I rewrite this as magnesium chloride with a subscript for the chloride ion. Okay, this means that I have 1 magnesium ion and 2 chloride ions in order to show a net charge for this compound. All right, so magnesium was 2 plus times 1 gives me 2 positive charge, and the chlorine was a negative 1 charge. And so 2 of those will then give us a 2 minus charge, which should then cancel out to a net 0 charge. All right, a couple more examples here. So aluminum and sulfur. We know the charge on aluminum is 3 plus. Okay, that's a cation with 3 plus charge. Sulfur is an anion with a 2 minus charge. So we put those next to each other, and then we'll again do our crisscross method. Okay, moving the 3 from aluminum down as the subscript for sulfur, and moving the 2 at sulfur down to be the subscript for aluminum. We'll then rewrite it as Al2S3. Again, this will give us a net 0 charge. So I want you to practice a few of these. So go ahead and pause the video. I have 4 ionic compounds here. I want you to practice this in your notes, and we'll go over what we came up with after you work through those. All right, now that you've paused the video, let's take a look at these. So calcium and sulfur. So calcium has a 2 plus charge. Sulfur has a 2 minus charge. Once we do our crisscross method, we have 2 calcium and 2 sulfur. However, okay, this can be simplified. So we want the lowest ratio. So if there's 2 of each, that's going to have the same ratio as if there were 1 of each. So we can reduce that to CaS. So 1 calcium, 1 sulfur. Okay, so for francium and oxygen, we know francium has a 1 plus charge. Oxygen has a 2 minus charge after our crisscross method. Fr2O for francium oxide. Okay, let's take a look at the next one here. Potassium and fluorine. Potassium has a 1 plus charge. Fluorine has a 1 minus charge. Crisscross method. And it's already in the lowest ratio for potassium fluoride. And our last one here, aluminum and sulfur. I believe we looked at this one, so Al2S3. So hopefully you got those. If you didn't get these, I would back up this video here and take a look at how we determine that again one more time. So, all right, so our nomenclature of binary ionic compounds exists of the name of the cation without the word ion. So for sodium chloride, we would just say sodium for the first part of the name of that binary ionic compound, and the element's name, okay? And then the name of the anion. So the anion was just chloride, right, for sodium and chloride. So here's our example, sodium chloride, okay? We just drop the word ion from the cation and then use the anion name in that name of that compound, okay? KBr is potassium bromide. And hopefully that has been helpful for you guys. So that is everything for the first part of our ionic bonding. Our next lesson will get into the ionic bonding compounds that consist of polyatomic ions. So let me know if you have any questions about this material, and I'd be happy to answer your questions. So I will see you guys in the next one. Thank you.